This is Algebra 2 at Trig, Unit 1C.3. We're doing operations with complex numbers. These numbers are called imaginary numbers. And the main thing that's imaginary about it is that we're attempting to work with the square root of a negative number. As far as you know, you can't take a square root of a negative number. No number that's negative is going to have a value multiply itself to become a negative. Negative 2 times negative 2 makes positive 4. So it's got to be the same number. So wherever we see a negative inside of a square root, we're going to pull that out as a value of I. So I is going to equal the square root of negative 1. Then we're going to go about the rest of the problem, solving it just as we normally would. And we'll have this I floating inside the problem. That indicates that this is really an imaginary answer. It's not a real answer on a number line. But at least we can come to a conclusion of what a type of answer would be. We'll talk more about when we square I, what do we get? When we square I, we're going to get the value of negative 1. So we'll jump down here. Here's a couple of examples of that. But we're going to jump down here and solve our first problem. Well, we have x squared and negative 13. So to get rid of the square, we're going to take the square root. And when we do that, we get plus or minus the square root of negative 1. If you want to put the 13 and the negative 1 inside the same radical, you can. So negative 1 times 13. That is negative 13. We broke it up into two factors. Well, you know now that I is the same thing as the square root of negative 1. So we separate that square root of negative 1, and we call it I, and then we just have the square root of 13. 13 doesn't break down, so we're done. That's our answer. We want the I after the plus or minus, but before the radical. Here's your second one. Think about what you need to do. Make a decision. We're going to subtract the 18 to the other side. That gives us negative 90. We're going to divide by 2. That gives us x squared equals negative 45. Now we can take the square root of both sides. We'll get negative 1. We'll get 9 times 5. Because when you take the square root of negative 45, 45 can be broken down into factors. It includes a perfect square. That gives us plus or minus. We talk about the square root of 9 first. Then we talk about the I, just like we would talk about 3x. We wouldn't call it x3. We call it 3x, like this is 3i. But we haven't been able to do anything with the radical of 5. So that stays inside the radical. Think about what we need to do. What's our first step going to be? We're going to bring the 33 over to the other side, which leaves us with 5x squared equals negative 30. Divide by 5. And when we take the square root, we know we have to have plus or minus. Because it's a negative 6, we're going to put an I in there. And it's square root of 6. So that's how we can solve equations that we typically couldn't do before. These solutions aren't really on the number line. These are typically where the graph crosses the x-axis. These equations, they actually don't cross at these locations. X squared in this first one is never going to equal negative 13. So that's why we have to come up with some sort of imaginary way that that can happen. This equation would be translated 18 up, opening upwards, is never going to equal negative 72. But if we use imaginary numbers, we can pretend in a different dimension that this actually is an answer. So we would all have the same sort of an answer as a conclusion of this problem. But because it has the I in it, it tells us that this is not a real answer. This is called an imaginary answer. So next we're going to talk about complex numbers. So with complex numbers, it's going to be written in the form of A plus BI. So your real number has to be first. So the A value is the real number. The number A is the real number. The number BI is the imaginary number. So the imaginary number has to go second in your answer. So there's some examples in here of how this can be put together, but we'll come down here and work this out. Notice how this first one is two binomials that are adding together. A very common mistake is to see parentheses and start to FOIL. This is not a FOIL question. This is an adding question. In fact, with the adding, we actually don't need the parentheses at all. We're adding a negative, so that's a negative 8. We're adding a 3, so it's a positive 3. You really don't need parentheses at all. You just group your like terms. So we get negative 8i because we're working with i's. You get positive 4 because it's 12 minus 8. It's 4. The 4 has to come first because that's the real number. That's the A value. The next one is a subtraction. Now really, you don't need the parentheses around the first binomial. That's really irrelevant. But you do need the parentheses around the second one because we need to distribute through. It needs to go to both terms. So this is going to be negative 24 and a positive 9i. Notice how I'm not writing parentheses again. If I write parentheses again, more people end up foiling the next answer and it comes out wrong. You just need to group like terms. Those two group together and they become 0. These two group together become negative 9. So there's a situation you're working with imaginary numbers, but the imaginaries all cross out and you're left with a real answer. This last one The parentheses are needed because you have a negative in front of it. You have to distribute that through. It's a -1 in this case. So when we multiply it through, it doesn't change the value of the number, it just changes the sign. So this is going to be 22, and this is going to be positive 5i. We're all set. No parentheses. You don't distribute the 35, you only distribute the negative. Now we come into that concept of having I times I. I squared, where we see I squared, we get the value of -1. Let's think about this for a moment. When we have square root of 3 times the square root of 3, that is the value of 3. The square root of 7 times the square root of 7 is going to be the value of 7. The square root of 4x times the value of 4x is going to be 4x. So what do we suspect the square root of -1 times the square root of -1 is? We all agree it's -1. So I times I is I squared. This is I times I. This is square root of -1 times square root of -1. So that is going to be the value of -1. So wherever we see I squared, we're going to use -1. You will not have I squared in any of your answers, final answers. So we're going to distribute, get -40i and positive 45i squared. And there it is. There's your I squared. It's not proper to leave it like that. So we need to write the I squared as a -1, which is going to turn the 45 into a -45, and we like to write the imaginary number second and the real number first. Here's a multiplication of two binomials. So we're going to use FOIL to answer this one. We multiply the front to get -32. Multiply the back to get 56i. The inner to get positive 8i. And the last to get -14i squared. Because I times I gives us I squared. So we group our like terms together. That gives us 64i minus 14 times -1. Well, the 14 times -1 is positive 14, which turns this into a -18 plus 64i. We group our like terms together. -14 times -1 is a positive 14, combined with a -32. All right, this is the same exact problem with some different numbers. Get -8, -10i, minus 4i, minus 5i squared. We're going to group our terms together to get negative 14i, and I squared is negative 1. The negative 5 times the negative 1 is a positive 5. With the negative 8 gives us a negative 3. So that's our multiply. And the last type we have is just working with complex numbers. When dividing complex numbers, you should multiply both the numerator and denominator by the conjugate. We've learned about that before. And the conjugate of a plus bi is going to be a minus bi. We have to change that sign. So just like we did it with radicals, we're going to do this with imaginary numbers. So the conjugate's going to be 5 plus I. We're only worried about the denominator. So we notice the denominator is 5 minus I, so we're going to write 5 plus I. And then we have to come through and multiply this whole beast out. But I times I gives us I squared. The bottom's going to give us 25, a positive 5i, a negative 5i, and a negative I squared. Well, we know what negative I squareds are, or any I squared for that matter. 15 plus 23i is our like terms. This is going to be plus 4 times negative 1. This is going to be the middle terms cross out. Remember, conjugates are going to give you no middle term. Those are always going to cross out. So we have 25 minus negative 1, because that is what I squared is. So this is negative 4, and 15 is 11. This here would be 26. So that looks like our answer. But our answer really needs to be grouped up with the real numbers and the imaginary numbers. You need to break your fraction up into real numbers and imaginary numbers. Move over to the next one. We're going to multiply by the conjugate. Remember, we're doing the conjugate of the denominator. We have to multiply this through and do the inner, do the outer. This would be last. So we got 5 times 4, which is 20, I times I, which is I squared. You can simplify that right away if you want, or you come through and positive 4i, negative 4i, and negative 16i squared. 4 times 4 is 16, I times I is I squared. We group some like terms together. Here we're going to get a positive 33i, but we're going to get 20 times negative 1, because I squared is negative 1. Now notice here, because we multiplied by the conjugate, the middle terms cross out. So we no longer have any i's like that. And the 16 I squared becomes 16 times negative 1. So we have a negative 20, and 7 gives us negative 13 plus 33i. And the denominator is going to be a positive 16 plus 1 is 17. And we'll group this into our two types. We got the real numbers and the imaginary numbers. We're going to multiply by the conjugate, distribute through, FOIL this bottom one, that's going to leave us nothing to simplify across the top because there was no I squareds. So we get 5 minus 5i. The i's cross out. That's the advantage of the conjugate. So we're going to have 1 minus I squared is negative 1. So that's going to become 2. We break that up into our two problems, the reals and the imaginaries. Last one's a little bit different. Last one has just an I. It's a monomial in the denominator. So a lot of people think about you got to change the sign or something, but that's only if you're doing the conjugate. So really, the only part that we need to change here is the I. We don't mind the 3. So we're going to multiply I to the top and I to the bottom. So we're going to distribute that in to get negative 2i and negative 5i squared. That's what happens when we distribute. This one's going to be 3i squared. We know that I squared is the value of negative 1. So we change the I squared into a negative 1 each time. This becomes a positive 5. We like to write the positives or the real numbers, happens to be positive, but the real numbers first and the imaginary second. And 3 times negative 1 is negative 3. Then we're going to write it with our imaginary numbers being written second. The imaginary numbers have the I, and that's going to be second. A lot of times we try to write the I more off to the side. Doesn't matter. It mathematically means the same thing. But we put the real numbers up front, a negative and a positive, make that fraction a negative. Often that negative is considered in front of the fraction. Okay, and then you have 2 negatives, which makes a positive, 2/3 with an I.